Here's another verify one, verify your identity. Again, you can choose whatever side you'd like to start on. I am going to start on the left, and I'm going to use my sum and difference formulas. So this one gets a little cuckoo. So for the sine of x plus y, that's going to be sine of x cosine of y plus cosine of x sine of y. Okay, and then for the sine of x minus y, that's sine of x cosine of y minus cosine of x sine of y. Nothing changed on the right, so I'm going to write that out. Okay, so this looks like a mess on the left, and I don't know what you're thinking to do, but I'm hoping you're seeing that you have two binomials and you could just FOIL them out. So when I multiply my first together, I will get sine squared of x cosine squared of y. And then when you multiply your outer and your inners, they're actually just opposites of each other. Sine of x cosine of y, cosine of x sine of y, and then you have, that's the negative, and then this, when you multiply those, are the positives, so they cancel out. And so you're really just doing minus cosine, when you multiply your last, cosine squared of x, sine squared of y. So again, your middle terms cancel. The right-hand side did not change, so I'm going to just write that out. Okay, so now you might be like, oh my gosh, I'm stuck, but remember your Pythagorean identities. I'm going to rewrite the sine squared of x as 1 minus cosine squared of x. Didn't do anything to the cosine squared of y. Again, over here, I'm going to rewrite sine squared of y with cosines. So that's going to be 1 minus cosine squared of y. Again, nothing happened over here. So now let's see, I'm going to distribute in and see how this goes. So I'm going to get cosine squared of y minus cosine squared of x, cosine squared of y, minus cosine squared of x, plus cosine squared of x, cosine squared of y. Nothing changed on the right. Whoops, too many s's and 2's. Okay, so on the left-hand side, you have a negative cosine squared of x, cosine squared of y, and a positive cosine squared of x, cosine squared of y. Those guys cross out, and you are left with your cosine squared of y minus cosine squared of x, which is what we wanted to prove / verify. There we are. And your last one, example for you, solve cosine of the quantity x plus pi over 4 minus the cosine of the quantity x minus pi over 4 equals 1. So again, you're going to want to use your sum and difference equations for cosine. So using your first one here, you're going to have the cosine of x, cosine of pi over 4, minus, I can put this in parentheses, sine of x, sine of pi over 4. Again, this is just substituting right into your summation equation for cosine. And then you're subtracting the cosine of x, cosine of pi over 4, plus sine of x, sine of pi over 4. And that still equals 1. Okay, so let's see what we have here. Notice you have a cosine of x, cosine of pi over 4, minus a cosine of x, cosine of pi over 4. Those guys, whoops, cancel out. You have a negative sine of x, sine of pi over 4, and then also the same thing here. So really you have two, negative of them, 2 sine of x, and then to save yourself time, sine of pi over 4 is root 2 over 2. Okay, so that's just to be clear, people, you have that equals 1. So what happens here? We end up with negative sine of x times root 2 equals 1. You'll divide both sides by a negative root 2, and then rationalizing that, you'll get negative root 2 over 2. And so now you can take the arc sine or the sine inverse of both sides to solve for x, but you're basically looking for what angle gives you a sine of negative root 2 over 2. remember which which quadrants you're going to be in. Where is sine negative? Sine is negative in quadrants 3 and 4. And because we're looking at root 2 over 2, you're looking at the pi over 4 family. And remember, we only asked in the 0 to 2 pi interval. And so we're only looking at 5 pi over 4 and 7 pi over 4. And those are your two answers.